Hello.
Good.
Okay, we can slowly start. I think if some of people want to turn on their cameras, I think it's a good idea, so we can see you. Cool. Vitalina. Yeah, just good. So we have hello. We have streaming on YouTube. We have people coming up here, and again, if people can turn on their cameras and we can see your faces and your reactions, I think it's a good idea. And we will have a short, like an interview in the beginning, and after that, people can ask questions. If you not sure how to formulate a question, you can write in the chat, and we will translate it. And also, yeah, the chat reactions are good, and in general reactions here in Zoom also probably know how to do it. We can start with this. We can just clap and welcome one and only the great Miller Pakett.
Well, thanks for inviting me. This is an honor and a pleasure to be a part of this meeting.
It's a great honor for us, indeed. And thank you for being awake so early. For those who do not understand the proportion, Miller is in California, and it is early morning right now. And it's a weekend, so it's a Saturday. Yeah, and I'm sure everybody knows who Miller is. For most of us, probably we know him as a creator of MaxMSP and Pure Data, and probably the whole paradigm of visually oriented programming adapted for artists and for musicians, also called modular graphical programming. And definitely we will talk a little bit about this. But as well, Miller is a professor and academic researcher, and also musician. And probably the first question can be, how do you actually introduce yourself, or what is your personal definition of yourself, if you have any?
Well, people sometimes ask my wife what I do for a living, and she says that she doesn't know. So,
recording in progress.
So I tell people that I do things and my wife doesn't know what it is. Really, mostly what I do as a job is I get involved in artistic productions of one sort or another, almost always with collaborators. And I usually play a more technical and research role in some kind of partnership that is aimed at creating either a piece of music or a movie or a piece of interactive art or something like that. And I really enjoy being part of these projects that I become part of. And so that is what really draws me into this as a field. But my talent is really mostly in design. And so what I do is design both software and algorithms for artistic problems or to open up artistic possibilities. So that means of course trying to maintain pure data, which is the environment that I do most of my work in, and it also entails making audio algorithms and decision-making algorithms for various kinds of situations that involve usually live performances. Right. So right now, my project is this. Let's see if you can see this. Yeah.
All right.
Right. This is
what is this? It's a
my
prototype.
Yeah. Oh, absolutely. This is going to be, hopefully, this is going to be part of a robot that will run around on a dance floor and interact with dancers. And what I'm doing on it is trying to make a program that can run on that very portable processor that can send and receive sound to a fixed station that will be running pure data. I won't be running pure data on that object, right? And also dealing with problems of robotic navigation, like figuring out what the orientation of the robot is and being able to drive motors to move it around. So that's this processor is a fairly new one. It's called the Espressif ESP32, and I actually have a version of pure data that can run on the processor, which I'm using for a slightly related project, which is to let's see, I'll get one of these. So this is an ugly throw pillow, right? So I have a project to make 15 or 20 ugly throw pillows that can whisper, so that you put them on couches in a gallery space or something like that, and people sit on the couches, and then they hear the pillows whispering, right? And that's
the idea is that they are wirelessly interconnected between each other.
That's right. Yeah. Mm-hmm. So so another thing that these processors make pretty easy to do is make wireless connections. And so what I'm envisioning is having 20 copies of pure data, all running on batteries, hopefully running all day on one battery, and able to whisper, to pretend to be whispering back and forth to each other.
So, right. But this is this so-called headless version of pure data, right?
That's right. Oh. Yeah.
Oh. And it is published, right, on your website?
I haven't published it yet because it doesn't work very well. Mm-hmm. But I will be publishing it at some point. I have written a paper about it for a conference that will take place in July, and the first actual showing of anything involving this version of PD, I think, will be in March. So I have another couple of months to get everything working, well enough that I can give it to other people and not have it be too painful for them to try to use. Right?
Great. But so this was your self-introduction, and basically you say that you are a developer of technical systems for other artists, right?
Mm-hmm. Primarily, that's right. Yeah.
Is that how you describe yourself for yourself, or maybe you describe yourself for yourself as an artist or as a musician?
Well, I don't have a good description of what I do.
But what about the academic career and being a professor and being a scientist?
Right, being a professor and being a teacher is one aspect of what I'm doing, and the reason I do that is that I'm interested in sharing what it is that I'm working on so that other people can use it. The point to that is that if you make some kind of technology and just keep it for your own artworks, it will only reach as far as your own artistic output reaches, right? Mm-hmm. So if you want your work to actually contribute something interesting to a larger collection of people, it's actually more effective to share the tools that you're developing than it is to simply make people enjoy your artwork, right? So I'm finding that the most important thing for me right now, or certainly the most effective thing that I can do in the world, is to develop tools that I use in my own projects, but which I also make available to other people. And the point to the projects, to doing the projects, is, first off, I think it's fun, and second, if I think that people who make tools should also use the tools they make, because if they don't, then the tools are intended for someone else, and then the tools will not be fun to use and might not be very well designed. So it's important to me to have myself using the tools that I'm building, so that I'm under the right kind of impetus to make the tools actually useful, right?
Yeah, so you can test them yourself as well and discuss with others who use them.
Right, right. Exactly.
And to improve them like this.
Mm-hmm. Yes.
And is this actually the process how pure data evolves? So you constantly challenge yourself with your creative challenges, but also talk with community and try to fulfill requests of international artists.
Right. Yeah, that's roughly the answer. A thing that I find out is that artists will make requests, but then the way you fulfill the requests is often not by giving the artist what they say they want. So, for instance, an artist might say, "I want this thing to have to make 1,000 voices of piano," or something like that. But really, what you want to do, perhaps, is to make an additive synthesis system, right? So that they can do that, but it would be a design that you thought about in a more general way, that has the constraint that it should be useful for the situation, but also should be more general than that. So I try very hard not to put features in pure data that are specific to a particular artistic style or a particular project, but rather to try to make things that are as generally useful as possible.
Well, we will talk a little bit later about the design of pure data and Max in general, and this the innovation of it. But one interesting question I'm sure everybody is interested is, why exactly electronic music, or let's say computer music, is so interesting to you, and that you dedicated your whole career to this topic? Why it's not more general digital arts maybe, or something else? Because pure data and Max, in the end, these are integrative instruments, yeah, and but you started them as music tools, and so why electronic music? What fascinates you in this field?
That's an interesting question. Well, the first thing to say is that music in general fascinates me. I'm very attracted to music and very interested in music, and like to make music, even if my music isn't as good as someone else's music. It's very fun to be a part of a band playing music, and so I've always wanted to have a career involved in music, right? But of course, I'm never going to be a concert pianist or something like that. You have to find the role that fits your own particular talents. And in my case, I guess two things happened. One is I was always fascinated by the idea of electronic music specifically, simply because it was new. I wasn't interested in old music. I was always interested in new music. And to me, the frontier of music right now really is mostly the electronic techniques. That's what's new in music as far as I'm concerned, right? And so, of course, I'm then attracted as a person who wants to do music. I gravitate to the electronic tools and techniques. But also that's a question of my own talent, because I'm really a mathematician, right? So it's much easier for me to figure out how to make a computer do a thing than it is for me to make my fingers do it, right? So So it's a very natural thing for me to become an electronic musician for that reason. Right?
Well, that's very interesting, because right now you mentioned that you're actually a mathematician, and we know that your major education, and your PhD were in the fields of math. And first it was MIT, where you did your bachelor's, and then you did PhD in Harvard.
Right.
And all of this was math and mathematics. And what I want to ask, do you think Shannon entropy and central limit theorem is still fun?
Well, I go back and think about that once in a while, because the the central problem that I was attacking, I never felt like I really solved. There was an inequality which I still think is true, and which I can't prove. And every 10 years or so, I go back and think about that again. But
just for everyone to understand, I quoted a topic of Miller's PhD thesis, which was Shannon entropy. And I don't know what it is actually. Yes. And
so I have two or three mathematics problems that still fascinate me, that I work on sometimes. But in general, it's very hard to do new mathematics. And so as a mathematician, you either are going to solve rather minor problems, or else you're going to attack a major problem and never succeed, right? Most mathematicians who try to solve some important theorem never are able to find it, because the field is maybe 2,000 or 3,000 years old, and most of the easy stuff has been done, right? So mathematics is a very hard field to really move forward in. But at the same time, it's very good for your brain to do mathematics. And it's also there is a wide range of things that you can apply mathematical knowledge to, such as music.
Yeah, but were you, in your childhood, for example, were you more musical kid, or you were mathematical kid? And how this transition happened? Probably at some point while doing mathematical problems, you thought, oh, I also like music. How did it happen?
Well, I was always very good and interested in mathematics. I was pretty good and interested in music. And I'd sort of always dreamed of being able to apply my mathematics background to some kind of musical field. But the only opportunity I found to do that was in electronic music practice. But in fact, that turned out to be kind of the ideal opportunity, because that's really where it's happening in music right now. So the two things were separate talents that I had that I can't really compare, because I was probably much better at mathematics than I was at music, but I was good at both, right? But finding a way to put those two talents together into one direction or one focus took me a long time.
But so just transitioning to a new, this next big question I wanted to talk. So at some point, you entered MIT Media Lab, right? And then you entered IRCAM. So that was a kind of process of you becoming from mathematician into actually one of the pioneering computer music personalities, right? And it was around 1987, 86.
Yeah, really, I started doing electronic music in 1979, when I was still working on my bachelor's degree at MIT. I started working in the laboratory of Barry Vercoe, who is the originator of C-Sound, who now lives in New Zealand. He was an MIT professor in the music department when I was a student at MIT. And so I started working in his laboratory just because he had a laboratory and he didn't stop me from working in it. And over the years, from 1979 to 1986, I guess, over the next 6 years, I became good enough at the technology of electronic music that they asked me to become a a paid researcher at the Media Lab. So it turned into a career that I could actually make money at. I thought I was going to have to stop doing that and become a mathematics professor. And so my education was all aimed at becoming a mathematics professor, which was sort of the default thing that I would have naturally done. And but this opportunity to actually make a living doing electronic music opened up for me, which was very, very lucky, I think.
And you moved to France at some point, yeah? How did it happen?
Right, that was sort of gradual. I first visited IRCAM, which is the center in France, in 1984. There was an international computer music conference in Paris at IRCAM. And so I had seen the place. The lab at MIT sent me there, right? So I was actually working for Barry Vercoe and writing research papers since about 1982, before the Media Lab started. So I saw IRCAM and heard some music. I heard Répond by Pierre Boulez while I was there as part of the conference. And then the next year, Barry Vercoe, my teacher, got a grant to go back to Paris to work on software for IRCAM. And he needed help, so he invited me to come along with him and work in one of the IRCAM studios on his project. So I did that the entire summer of 1985, and met the people at IRCAM and started and found out about some of the music productions there, and managed to get invited to work on 2 music productions at IRCAM. So the way IRCAM worked at the time, and I think still this is pretty much the way IRCAM operates, is they will hire they'll commission a well-known or very successful music composer to write a piece of music involving electronics. And they at IRCAM will handle the production of the electronics of the piece, usually by hiring an assistant who will take care of that particular production. Right. And so I was the assistant for a pair of productions that were scheduled for 1987. And as a result, I started traveling back and forth between the United States, where I was still a student, and IRCAM, where I was working on this music production. Right.
So this Jupiter piece, yeah, and some other pieces, I think related to planets or.
Yes. So the first 2 productions premiered on the same day, which was a pretty dangerous thing to do. It was Jupiter, which was by Philippe Mannery, and another piece, Aloni, which means halos, which was by Thierry Lancino, another composer. And so I worked very hard with both Philippe and with Thierry for the 2 years from 1985 to 1987 to get these 2 pieces ready to present. Right? And by that time, everyone at IRCAM knew me and they wanted me back. So then they hired me to continue working there.
And was Max initially developed for one of those pieces?
Sort of. I had been working since 1980, in fact, on trying to make a real-time computer music system that would be programmable and able to put sound out of speakers in real time as a result of live inputs. So that was the task that I set myself to. As soon as I had spent my first year working with Barry Vercoe. So in the summer of 1980, I got started on that. And so I continually refined the ideas that I had. And at some point, maybe around 1985, I started calling the thing Max. But the thing that people know as Max, which is the graphical programming environment, that was not ready until 1988. So really, that was a result of about 8 years of continuous development.
Continuous soft and something. It's a very famous sample, which we have in examples in pure data and Max. Continuous soft.
Continuous, soft, and relaxing. Yeah, right.
Exactly, and it's done by your voice. So I think everybody recognizes it. No,
it's not me. No,
it's not your voice. Oh.
No, it's a radio announcer.
Oh, really? But you have the same intonation. But was Max initially designed for MIDI control? Because this is a common kind of people think about Max, that it was initially designed to work as a control system for MIDI.
Sort of. It was originally designed as a control system in general, but the only real-time input and output protocol that existed in 1988 that I could use was MIDI. So MIDI was always a part of Max from the very beginning, but only by necessity. My own thinking about my own thinking started in 1980, which is before MIDI existed. And so MIDI to me was a thing that I could use, but was not actually the focus of the program at all. It was simply one protocol for communications. Also,
please.
Also, the synthesizer that I was using at the time was the so-called 4X, which was the digital synthesizer that had been developed at IRCAM. So the version of Max that, whatever you say, the application of Max that we were using was not in a MIDI studio at all. MIDI was only the one protocol that was in common between the Macintosh computer and the 4X synthesizer.
So initially, Max was kind of a control interface for that IRCAM synthesizer.
That's right. That's right. And yet, as soon as it became possible for me to distribute it, which was you could put it on a diskette and you could just copy the diskette and give it to people, right? So people started getting copies of the prototype for Max. And of course, nobody outside of IRCAM had access to a 4X machine. So people started using it immediately using commercial MIDI synthesizers.
Were they modifying it by themselves? So did they have to implement MIDI, or you had already a MIDI?
No, MIDI was implemented. You had to buy an interface to get to get MIDI in and out of the computer. But other than that, it was a standard thing by that time. Yeah. And it was a standard part of Max. Right?
And when the graphic interface was actually attached to that?
I started working on that in 1987, just after Jupiter, just after the first piece by Philippe Mannery, Jupiter, was premiered. That piece was so much trouble to write and to produce that I went back and made a graphical interface so that composers and even designers could see what was going on in an easier way than what was possible before. And so it was so adding the graphics was a direct reaction to how difficult the production process had been up until that moment.
And you had to build this graphic interface by yourself.
Oh,
right?
yeah. Mm-hmm.
So you designed it. And were you thinking at that moment about aesthetics, and or was it a pure functionality?
There, some of both. The aesthetic angle of it was that that I wanted the interface to be very clean and not distracting. So I didn't want to have the screen look pretty or anything like that. I wanted it to be very much like how an old text editor would look, right? I just wanted it to look like a computer. And this is because I don't know why I thought that was a good idea, but I still think it's a good idea to make things very, very plain and simple on the screen. But another aspect of it was not really my choice. The Macintosh had two colors. It had black and white, and that was it. There was not even gray. And also the screen of the Macintosh was about this size. I think like that. I think it was 3 inches by 5 inches, right? And as a result, it was very important to save every single pixel that you could possibly save in the interface. And so I didn't do anything about, all the patch cords were exactly 1 pixel wide. The box boundaries were 1 pixel wide, and the text font.
But they still are, no? In pure data.
PD, yeah. Although now, if it's a signal, if it's an audio signal, the lines are 2 pixels wide.
2 pixels, yeah.
Right. And that's my only concession to.
but do you think, or would you agree that actually the idea of this modular software interface, along with the ability to visually code, to patch things in real time, that this was actually the primer innovation? Or you would not agree with this? Because when I was discovering Max, and I know for many people, maybe it's a bit different, because for a lot of us, it was a transition from digital audio workstations with fixed interface into this modular. And for you, would you agree that that was one of the major innovations of your software, the modularity?
It's almost the opposite, because before DAWs existed, there was no such thing as a DAW in 1988, right? So everyone who did electronic music was building things. People had analog synthesizers that were patchable, and then people who used the computer languages such as C sound actually described the audio techniques that they were doing by drawing patches on pieces of paper that would show signal flow, right? So everyone thought about electronic music creation as a modular process, and I was working on modular systems, since 1980, because that was what everyone thought was the correct thing to do, and I agreed, and it is.
You mean you were designing modules for modular synthesizers?
No, still for computers. So I was using various kinds of computer hardware to make essentially real-time systems that started out looking mostly like C sound, with unit generators with a text language. And everything was controlled by text languages all the way through 1987. And you can describe modular synthesizers with a text language. You just have to name all of the connections and write text to say what the connections are. But then it can be very hard for people to visualize that. But at the level of C sound, it's okay, because typically you only have fewer than 100 modules in an instrument, and so you can sort of deal with it conceptually. But when the number of modules that you're using gets up to 1,000 or so, then it gets to where you really need a picture, right?
What I wonder is, were you deliberately thinking that the introduction of this visual possibility to patch things will actually open the door to electronic music, to, let's say, explorative, computer music, to a lot of people for whom learning a text code is very hard, but visually it makes it much easier. Did you think about it?
Actually, I was pretty stupid about that. I was working even after Jupyter. I was still working on reusable modular text languages. And at one point, I was showing what I was doing to the research director at IRCAM at the time. And so I was showing him these lines of text that were oscillators and stuff like that. And he asked me, "Do you really think composers are going to want to learn how to do this?"
So it was him who introduced this idea. What was his name?
Jean-François Alois, right? And he was pretty influential on me. He's unfortunately dead now, but he was he sort of forced me to think about the fact that composers were not likely to want to use text languages to do everything that they were doing musically. And probably other people were telling me similar things, but that's the conversation that I really remember. And at that point, I got myself onto a Macintosh computer and started learning how to draw little boxes on the screen. And then managed
so
to get...
you were never encountering doing GUI graphics before, right?
No. I had seen them because actually there was research at at MIT even before even 1979 that was showing editors that could edit patches of C sound unit generators. Right, there was a thing which was never published called OEdit, which was the orchestra editor, and it was a graphical system where you could draw an oscillator and draw an envelope generator and all that stuff.
Were you aware about the general purpose languages based on the same principle? Because the earliest mention I can find is 1967, and a bit later they were developed in Xerox, what was formerly Xerox research. And
right.
They were using the touch screens, like early touch screens, and there was already this idea of general purpose programming using the schematics visually.
Yeah.
Were you aware of this?
I didn't know about that. And furthermore, I didn't care what the computer science people were doing, because it was, I knew computer science people, and the computer science education is almost inimical to art. You know, the way they thought about things was not ever really going to make a good plastic artistic tool, because computer scientists actually already have built-in notions of how people should structure projects, right? And I didn't think that that the program should enforce structure on the user. I thought that the best kind of program for a composer to use was simply pure chaos, with no organization at all, right? Because because composers are people who organize things, right? So I don't think the computer should be the source of organization, right?
Oh, that's very, very interesting. If you Google chaotic pure data patch, you will see a lot of very funny images, how this interface is used to completely cover screen with chaos.
Right. And computer scientists look at those pictures and they burst into tears sometimes. They just it's just not, it's terrible, right? Whereas an artist can look at that and just sort of feel the possibility in a system that's that chaotic, that's that unorganized, right?
I really think that the aesthetics of that interface is also one of the very influential things, I must say, but maybe people can disagree with me. And with this, I actually want to open for discussion for the questions from our audience. I mean, of course we can talk further, and I have a lot of more questions, but our declared half an hour of initial interview has ended. And right now, guys and girls and everyone, let's do the Q&A, right? If you have questions, please ask. If people will be reluctant a little bit, I have more questions, so we can continue. But let's hear what people say. Guys, you can raise a hand, or you can just directly switch your mic, unmute yourself, and just...
Can I ask 2 questions?
Oh, hello.
Hi.
Yeah, sure.
Yeah, okay, nice. First of all, thanks, Miller, for being here, and thanks for all of your works. And my first question is, I still have some connection to Cycling Center 4, because the next part of the question is, do you know if Cycling Center 4 is planning to import Python in the MaxMSP? Because as far as I know, Python is a really powerful engine to work with machine learning, and such things, and I think it can be applied. Like JavaScript was implemented right in the Macs. So is Python going to be there? That's the first question.
Yeah, well, I actually don't know. I talk sometimes to the developers of Macs, but I'm not really in their day-to-day planning, so I'm not going to be able to tell you what they're going to be doing in the future with any level of detail.
Okay.
I believe it's possible to use Python from within PD. So if you wanted to try to use PD, then you probably can get a hold of the PD's Python portal, right? But I've never used Python myself, so I can't actually tell you in detail how you would do that.
Okay, thanks. And please.
Oh, the other thing I should say is Python is very popular right now, but there are better languages. In fact, there's one called Julia, which is named for Gaston Julia, who's the inventor, or well, I don't know, mathematician who first thought about fractals. And if you look at the design of the Julia language, you'll find that it's much better designed than Python. And people who are doing number crunching are starting now to move from Python to Julia, I think. I don't know whether the machine learning community, which, you know, the whole TensorFlow crew, I don't know if they're going to move from Python to Julia or not. But TensorFlow, which is the most powerful linear algebra package for doing machine learning that I know of, it doesn't actually have a specific language. You can use it from a variety of different languages. And so I would suggest, if you're interested in doing machine learning, see if you can use TensorFlow directly, because then you can use it from other languages than Python. And that will be a better way of preserving your work if Python itself falls out of favor in the future.
Okay, I see. Thanks. And the second question is, as far as I know, you're one of the developers of the wavegun. That's right.
Of wavegan? Well, I was the advisor for the person who did it, but the truth is I didn't do any of the actual work. I had many conversations with him about it, but I was able to understand it at a mathematical level, but I didn't do any of the coding at all. Yeah.
Okay, I see. So my question about wavegan was, what's the future of the wavegan? But as you're a non-developer, I don't know if you're able to.
Yeah, you should look at the work that that the author of wavegan is doing. His name is Chris Donahue. He's the first author on the wavegan paper, and he is right now a postdoctoral researcher at Stanford University. So he's still publishing what he's up to, and I think he's going to be a leader in the field of machine learning and music. I think he's just brilliant. He's very smart and very hardworking. So I think whatever he's doing now is probably really good.
Okay. Thanks a lot.
Oh, thanks to Danila I don't know, for telling us how to find Python. Yeah.
It's a Thomas Grill website,
right.
I think.
That's right.
From Austria.
Right, and I had forgotten that was who did it. Yeah. Oh, and if you're using Macs and want to use Python, you can use the PD tilde object in Macs, which gives you a Macs object that just runs pure data inside Macs, and then you can run Python inside pure data. That's one way you can do it. If you really want to.
Do you ever use Macs for your own creative purposes or for education at some point? I mean, Miller.
I never actually use it, but I did just download it yesterday because I needed to be able to test a plugin on a Macintosh, and I needed a plugin host. And if you need to host a VST plugin on Mac, a VST3 plugin, the only way I could figure out how to do it without paying for something was to download the Mac's package and use it as an evaluator for a month. So that's what I'm doing right now. So I have one Max patch sitting on a Macintosh that's loading a VST.
And it's the first time you use Max in how many years?
Oh, I don't know. I haven't used Max on an artistic project since I started working on PD in 1996, right?
Mm-hmm.
So I'm very out of touch. I can still remember how to use it pretty well, but but it feels strange to me now because it's quite different from pure data. Yeah.
Guys, any other questions, please?
Yes, I have a question. Thank you for your speech. I've been thinking recently about machine learning, and I've been thinking about how machine learning could actually help in creative process, because I think it can, in a way, disturb it, because it can give us like already given results, given decisions for us, but at the same time, it can give like something unexpected. And how do you think, how actually machine learning would influence music in future, and which possibilities, which ways it would like influence it?
Well, let's see. So my answer is probably not going to be the same answer that anyone else would give. The first thing is that I haven't been able to, myself, I haven't actually really seen in the so-called deep learning algorithms now, the variational autoencoders and things like that, I haven't seen any really strong possibility for art making. The reason for that is that the examples of art that use machine learning at that level tend to be about machine learning itself. And machine learning isn't, for me, an interesting subject for artistic exploration. Now, if your artistic practice is all about the way the world of the network works right now, or the way commerce works right now, then the sort of weirdness that machine learning has added to our lives is perhaps an interesting artistic object to consider in its own respect. And in that way, these deep learning algorithms and the sort of funny images that they make and the funny sounds that they make are interesting because they're weird and funny and distorted, right? For me, the interest in machine learning is at a lower level, much more the sort of thing that Rebecca Fiebrink and Sam Pluta are doing, which is using it to design mappings between controls and synthesizer parameters, right? That to me is very interesting, because you can give yourself 2 or 3 dimensions of control, 2 or 3 sliders, or even just a hand shape, right? And then you can map that into 100 controls for a synthesizer and make the synthesizer make unexpected sounds, and perhaps sometimes even learn how to make them repeatably, right? That to me is very interesting. And that doesn't require the deep learning technology at all. That simply requires back propagation neural network learning of the sort that was already well known in the 1990s. There's a paper by Michael Lee and David Wessel that describes an early example of this from, I think, 1990. Let's see. So I think, let's see. So I'm going to just give you the authors. I can't remember the name of the Michael Lee and David Wessel. Only one E, like that. And if you go find a paper or papers written by those authors, you'll find that that people were using neural nets to try to train additive synthesis synthesizers to make timbres, given a small number of controls, and given a training set of examples, right? And that to me is extremely interesting. And I should type the name Sam Pluta. If you look at Sam Pluta, he's working in Python, in fact, using, I've forgotten the name of the Python machine learning package. And he has been very recently doing a similar kind of a thing, which is 4-dimensional control of a synthesizer that has 100 or so parameters on it. So that to me is a very interesting direction to go in. And you can't really call it machine learning so much. I mean, it's really more like curve fitting, right? It's more like, I'm going to give you a bunch of points of some function that I think exists, and you, the machine learning algorithm, have to make a surface that goes through those points. And then between the points, it does other interesting things, or outside of the points, it does other interesting things. And then you can explore that. And that to me is very interesting.
Thank you very much. Yeah, I think it actually, I've been on workshop from Flucoma guys. They do the package from Max, and I think they're actually doing this, and it's amazing. The results are amazing.
Yeah, I should have mentioned them. They are very interesting, and I haven't actually downloaded Flucoma myself to try it, but it seems like it's one of the most interesting things going on in machine learning for computer music right now.
Yeah.
I just wanted to say that if you are typing something to chat, I somehow do not get.
There is some stuff in the chat which I've been trying to follow.
Yeah. Well, anyway, we also have some questions from YouTube stream. Yeah, and Vitalina can just ask.
I see. Okay, I see one question that just came in from Roman over the chat, which is just to make the question very simple. Do I have strategies for trying to control the complexity of patches in PD? In other words, when you're making a patch in PD or in Max, eventually you end up with a sort of a salad, right? And then it becomes very hard to debug and very hard to organize. And I don't have a very good answer to that. I can give you examples of how I organize patches. In particular, if you go looking at the, I'll type this out, the Pure Data Repertory project. I think, actually, you know what? That's one possibility, but there's a better thing, which is, I think it's here. Then it's going to be ideas. You know what? I have to look and see where this thing is. CD public. No. There it is. No. You know what? It doesn't exist yet. Okay. So anyway. There is a thing which I call the null patch, which I think is somewhere on the web, but I can't find it now, which is a patch that does nothing except organize itself. And when I'm making a new computer music application, I always start with this null patch, which is just an empty piece of music that I can then put my own stuff into, but it supplies the basic structure that I always reuse now. For controlling signal routing and levels and things like that, and sequencing.
So it's like a folder, like macros.
Yeah, right. But I'm sorry. So Sergey, you had questions from the YouTube chat.
Yeah, there are some people who ask from the streaming, and Vitalina can probably read them.
Oh gosh. Well, one thing I keep telling people about is a thing that Johannes Smolnik did that I saw 20 years ago, I think, which was a boxing match. So he had two people, maybe about 20 years old. I think he was one of the boxers, and they had boxing gloves that had sensors in the gloves, and every time one of them hit the other, then there would be a sound coming out of the speakers, and it was just a horrible spectacle to watch. but it stayed in my mind for many years because of the grotesqueness and the strangeness of the spectacle of hearing a sonified fight, basically.
So it's not exactly the most beautiful thing, but maybe most bizarre.
Or the stickiest, the most, what's the right word? The most artistically successful in the sense of disturbing, right?
Rememberability, yeah, it's rememberable.
Yeah, memorable, yeah.
Memorable, yeah. Okay. Any other questions from YouTube?
I like it. It's a good thing. I'm not going to do anything like that in PD, because that is it's a larger kind of a system than I really want to produce myself. People who want to do that kind of work in pure data have a couple of possibilities, which are not as good as Gen, I should say. So I think Gen is a powerful and good and interesting thing. Do I? Not really. I'm trying to think. I don't have any analog synthesizers at the moment. I used to own one, but I gave it to UCSD. It's an old Buchla synth. But at the moment, all of my synthesizers are digital. Yeah. Wow. Yeah, the most stable thing you can do is to make a sawtooth generator, phaser, and then just output it as audio, right? Because that's very stable. But then, of course, that means that you have to have whatever receives the clock be able to deal with an analog falling trigger, right? Here's a recent one. This thing, Inside Computer Music. This is a good book. It contains 9 chapters, each of which considers one composer who works with computers in one of 9 possible different ways. And so the composers involved are quite varied. Philippe Manoury is one of them. And so I get a little bit of a part in one of the chapters, but other composers include Hildegard Westerkamp. So I should look and see, because I'm now forgetting everyone's name. John Chowning is one of them. Let's see. Oh, we have Francis Daumont, who's taking care of tape music, right? Hildegard Westerkamp works in environmental sounds, right? Trevor Wishart, who's of course the most brilliant sound designer of them all, I think. Jonathan Harvey, who's famous. Court Lippy, Natasha Barrett, right? That's the name I was trying to get. So, and this goes into detail about their work, and you can even download videos and patches. I think it's all implemented in Max, but I'm not sure. But you can download patches that realize aspects of these people's work. So for John Chowning, for instance, you download a patch that can actually recreate the piece Stria, and you can see in all the detail that you want how the piece is put together. So this is a brilliant book. It's the lead author is Michael Clark, and there's also Frédéric Dufeu and Peter Manning. So it's out of Huddersfield in England. So that's a good book. I don't read a whole lot of books. Oh, another book I'm reading right now. This one is tiny. It's a book called Switched on Bach by Roshanak Keshti. Let's see, I'll put it up here where you can see it. There, that one, very thin, and is an interesting sort of cultural investigation, or a cultural, not investigation, but even reflection on the early work of Wendy Carlos in making Switched on Bach, which is one of the most formative records in electronic music. Yeah, so interestingly, but neither of those books is really about techniques or technical development or research. They're both really about music and the environment in which the music is made.
Yeah, but perhaps because you are inside the technical aspect already yourself.
Yeah, it's true. Yeah, so that's all stuff I know about. Yeah,
you know,
it's true.
a lot.
Yeah.
But well, maybe related to this is a question from email we got from House Ryan's. Is physical modeling synthesis is the best way to achieve materiality of sound in terms of artificial methods? Could you talk a bit about this kind of synthesis? Where is it heading in your opinions, or the future of it? And another part of this question, what do you think about virtual reality?
Okay. Yeah, I think I have to answer those separately. So I'm actually very interested in poetic physical modeling, which is to say, trying to capture aspects of how something is acting by thinking analogously to physical processes, but not in fact modeling them specifically. So, for example, if you have a drum, drums are not linear. The harder the membrane of a membrane drum is moving, the more tension it is under, and therefore the higher the frequency of all the partials that it makes, in some sense, right? And that is so if you just play a drum sample, then if you play it soft and if you play it loud, you get the same sound. And of course, you can then cheat by filtering it and things like that. But if you make a physical model of a drum, then you send a small impulse to the physical model and it does one thing, and you send a big impulse and it does something different, and it can be made convincingly different, like a drum, right? So that leads me into a consideration of basically recirculating networks like reverberators, except nonlinear ones that you can build that respond to energy, or sort of electrical analogs to energy that you put into the circuit that make it then disturb its own vibrational modes and do interesting kinds of things. So that's a kind of physical modeling that I get involved in. Let's see. You can find a little bit about that, about my approach to that in a paper that I've written, which I call Infuriating Nonlinear Reverberator. So I'll just type that out. Like that. But I should say that maybe if you're really interested in following this further, probably the better thing to do is look at some of the lectures that I've done on this technique in synthesis classes that I've taught. Although I'd have to go look at the index to figure out which lecture you would want to look at. Right. So that's a partial answer. The other part of the question was about virtual reality, and I'm sort of interested in augmented reality. In a theoretical way. I'm not terribly interested in virtual reality. So the idea of trying to make worlds that exist on a screen is not interesting to me, because the real world is actually a good deal more complicated than anything you could make virtually. But the idea of augmented reality, the idea of being able to put labels on things in a physical room that only appear to you and might not appear in the same way to other people in the same room, that has interesting. That has an interesting feeling to it that I would be interested in exploring, although I haven't done any explorations in that myself yet.
I just wanted to mention, if you are trying to type something into our Zoom chat, we actually do not receive it somehow.
Yeah, I'm seeing it okay, right? Right. But you don't see what I'm doing. In fact, I don't know if the rest of you can see it or not. So what I should do is.
You just type onto chat and you, I think, push enter. Yeah.
Really? Okay, but Vitalina can see it. Okay. Yeah.
Maybe the problem.
It's fine with me. It will, of course, be data compressed because of Zoom, but Zoom does a pretty good job, in fact, of reconstituting human voices. So it's fine with me. I didn't actually make any move to record my own voice here, but you're welcome to it if you want it. If you want better samples of my voice, you should probably go look at my lectures, because those are recorded directly from microphone to video, and they will probably have higher quality than the Zoom version, but maybe Zoom is good enough. I don't know. Anyway, certainly you have permission. I mean, everything that I say, yeah, that's right. Yeah. But everything that I do in a forum like this is basically public, as far as I know. So anyone who wants to can use that for whatever they want to do with it. Yeah.
Yeah, actually, for those who did not research it, I think most of the Miller's lectures available on his website. I think at least for the period when everything became online. Yeah, I think you post all of your Zoom lectures just into public domain on your website.
Right. In fact, I started doing that maybe 5 or 6 years ago. I'm planning to retire this spring. And so a project for the last 5 years has been to try to get as many lectures as I possibly can recorded, so that and indexed, so that it will be easy to go back and find out what I did. And then later on, if I have time, I'll write some of it up, but at least the videos are there. Yeah.
Yeah. So guys, we have. Yeah, I just wanted to say we probably will have the last half an hour, because we were planning it for 1.5 hours, and then probably we will end up, but still about half an hour. If that is okay with you, Miller, if you are tired, you can say bye-bye.
No, I'm just waking up.
Okay, please, Vitalina.
It's it is worth reading. It's quite dated now. It explains well, I should say the good thing about that book is that it goes into detail also about existing real electronic music pieces. The only thing I should say about that is that most of the music that they discuss in Dodge and Juris also gets discussed in later writings. In particular, I think Dodge and Juris talks about Stria by John Chowning, talks about Mortuos Plango Vivos Voco by Jonathan Harvey, talks about work by Jean-Claude Risset. I forget which piece, maybe In Harmonique. And also talks about some work by Charles Dodge himself, speech songs. Right? You might find that all of that music has become pretty well known over the last 20 years, and there is much more writing about it. In fact, if you're interested in Charles Dodge, I wrote a thing about that in a book that I co-edited a while ago. And John Chowning and Jonathan Harvey are treated well in this Inside Computer Music book that is out now, which I would recommend. So Dodge and Jurus is a good book, but it's old now. A lot has happened since then.
Okay, the guys in Zoom, maybe somebody wanted to ask a question in person. Maybe I would like to ask you a little bit about your general philosophy on intellectual property. Yeah, in relation of what you do, and you were touching this a little bit, talking about Max. And I know there is an article you wrote about who owns a software.
Oh, yeah.
Yeah, and it is on your website, but maybe you can comment right now because it was some time ago. Also in relation to the Max history, yeah, so at some point, I think IRCAM obtained rights for the Max, and was that the reason for you to start developing pure data?
Yes, in fact, well, there were two sides of that. One thing, yeah, so I never owned Max. Max was always owned by IRCAM when I was working on it because of because my work contract basically made all the software that I created the property of IRCAM. And this was okay with me because after all, they paid me. And the other thing is they did a lot of work to make Max possible to publish. So they were the ones who went out and negotiated with actually eventually 3 different companies to try to find a way to publish Max as a program. When Max came out in 1990, there was no such thing, as far as I know, as downloading a piece of software. The way you obtained Max was you walked into a physical store, and Max was a box on a shelf, and you would take the box off the shelf and you would pay $200, and then you would take the box home and put a CD into your computer, and that would be Max, right? And that was the only possible way that you could distribute such a thing widely would be commercially. So Max, because of the age in which it became a thing, pretty much had to be a commercial project or product in order to have any impact in the world. By the time pure data started to become available in 1997, the network was a good place to distribute software. It was easy to distribute software electronically. And at that point, all the costs of physically distributing a piece of software disappeared. And at that point, the correct choice, in my opinion, was to make the software open source or freely available. Because my intention, in fact, the intention of, or the desire of any software developer is to have their software reach a maximum number of users, right? That's because when people use your software, that's what validates you as a software designer, right? So the way I saw to get pure data out in the widest fashion that I could was by making it open source so that people could just take it and use it, right? So both of those models are correct within their own assumptions, right? And Max is still, the Max commercial model is still alive and well. And for instance, schools like universities in the United States mostly teach using Max instead of pure data because it's much easier to teach. The community is larger. Well, no, the community isn't larger, but there are more resources put into documentation and into helping beginners use the program, and these things are all paid for by people who buy the software. So there's an ecosystem there that money is needed in order to get people, to keep the website alive, to keep the forums alive, to organize meetings and all that stuff that they do that makes it easier for people to approach Max MSP and use it, right? But when you get out of school, then maybe you don't. If you're an independent artist, you might not want to spend $500 or $1,000 on Ableton Max for Live, I don't know what, right? Instead, you might discover that you can use the same principles, or you can program according to the same principles using pure data if you want to. And then you can learn how to use pure data and do everything that you do on Macs except for free, right? Incidentally, this processor here that I'm working on porting pure data to costs $10, right? So, of course, you have to put some kind of audio output on it, right? So that's another $6. But anyway, it's available to any hobbyist anywhere who wants to try to use it and learn how to use it.
So, I mean, conceptually, you are not against people using pure data in commercial purposes. You are not against it.
No, in fact, people do that all the time. In fact, I don't even really know the extent to which pure data is used inside computer games, for instance. The first computer game to use PD was something called Spore, and I think that was almost 20 years ago. So I presume now there's that it's considered one of the possible ways of putting audio inside a computer game. It's just run pure data in there, right?
It's through using the libpd bridge, yeah.
Usually, yeah. Although Spore was done even before libpd. The developer of Spore just took PD and took the graphics out of it and just used the signal code, right? The other example of that is Max MSP itself, because all the tilde objects are actually derived from the tilde objects in PD.
So MSP MSP is in a way implementation of pure data.
It's actually a port. It's derived directly from the PD tilde object code.
Wow, that's very interesting.
Of course, they took it very much further than that, because PD has 200 objects in it, and Max MSP has maybe 2,000. I don't know. So I
think the power of PD is in its simplicity. It's also kind of, for some people, it's a downside, because Max gets gradually more and more complicated and has more and more features, and that's why also it has to be commercial. To compete with other, there is a software on the market on which Max partly is this integrative multimedia software like Touch Designer or some other, so they can compete a little bit, and they have to debug, so they have to maintain it to be very, very stable. And I think the biggest issue people have with pure data that sometimes you have to work really hard to find a solution for some thing which is maybe not documented, and you need to go into community to ask questions in this email list, or maybe in a Facebook groups.
People are often afraid to write the email group, right?
Yeah, because you never know if you will get the answer.
Yeah, right. Who knows?
How many hours you will spend on this thing, which in Max in John most probably can be done, like described somewhere in help and so on.
Yeah. So there's a question in the chat by Roman, who's asking, are there plans for further development of PD? And the answer is yeah, lots, but not. But I don't have a good roadmap. I tend to do things when I have to, and what I want to do is make the graphics aspect of PD, the data structures element of PD, much easier to use and more and better designed. But I keep thinking about how to do that, and I keep on getting stumped. So that's sort of still in the future, because I can't find my way to the design that I want to have in the end. And there are a bunch of smaller things that I want to do in PD. Well, here's a stupid one. I want to be able to have PD open its interface and then close its interface, but continue running, so that you can put in an installation. But then when the installation does something that you don't want, you want to be able to then SSH over to it and then reopen the GUI. So I want the GUI to be able to open and shut dynamically, right? Very simple idea, but very important because that makes it much easier to debug patches in PD.
But you can just minimize a window, no?
Yeah, but if it's, for instance, if you have a Raspberry Pi, you log into the Pi, you start PD, and then you have to stay logged in if you want to keep the window, right? So you want to be able to log out, disconnect, and then later log back in and then see what's going on, right? So it can't just be the same window, it has to recreate it, right? And I think it's easy to do. I just have to sit down and work out all the stupid details. Yeah.
And but can we say that you are in general advocating for open source, or is it only right now when there is internet and in a way it's natural to distribute software openly?
I would say that in general, I am in favor of open source as a not so much for moral reasons as for practical reasons. And the practical reasons are that open source code is much more likely to stay stable than commercial code. So commercial code, for instance, if you're publishing a program for people to use, every year you have to sell more of them. So you have to keep changing the program so that you can sell people the new version, right? And as a result, the things continue changing so that patches that ran on Max 4 maybe won't run on Max 8 anymore, right? In PD, you can still run patches that were written in 1997. So that's a very strong plus for someone who's trying to develop things that they want to have be stable artifacts, like an artist would want to do. And the only way to accomplish that is, as far as I know, is to go with open source software, because the commercial software simply never can stay stable for that kind of period of time.
That's a difficult question because software relates on the hardware, and hardware keeps being improved, and also relating to operational systems, which are in majority cases are commercial, so they get re-released. And
and one of my main headaches right now is that, Pure Data, every time there's a new version of the Macintosh OS, I have to go mess with Pure Data to get it to work with all the changes they made, right?
Would you therefore advocate for Windows?
Well, I prefer Windows personally to Mac OS because basically because it's much more stable. You can run old programs on it, but in fact, if you're going to run Windows, I suggest you just run Windows XP, because you'll always be able to run everything on XP.
I think it's 1998. Yeah.
Yeah. And it's good. I'm running a virtual Windows XP. That's how I test PD. Yeah.
A nice advice, especially for young people, right?
Yeah. But if it's Windows, keep it off the network, because as soon as you make a network connection, you're going to get some.
It's a headache. It gets trouble. Updated. Yeah.
Oh, it's worse than that. You'll get malware instantly, right?
Oh, really?
Yeah, Windows is wide open to malware, or at least Windows 98 is, or sorry, Windows XP is. Yeah.
Okay.
Yeah, so you have to be very careful about that.
A lot of advices from Miller Pakett, and guys, does anyone have any questions in Zoom?
There's one question from Andriy Shishkovsky. Hello, yes. Can you please mention the most outstanding art projects created with PD that went beyond my ideas as PD designer? That's interesting. Trying to think. The thing is, things that went outside of my conception of what PD would do are always things that are unexpected in some way. And so they're all totally different from each other. And so then it's very hard to understand. It's hard for me to say what the most outstanding one of those things would have been. Maybe it's the, this is again, Johannes Smolnig's idea, I think. But he was making live coding performances where he would have one copy of PD, but he would have 2 or 3 different users, each with a copy of the patch on their own screen, and they were all editing the patch at the same time, competitively. Right? And that made for very interesting and very strange performances. So that was something that surprised me a good bit. So what he did was he made a program that sits between PD and its interface that then splits the messages from PD out to 3 different computers. And then 3 different users are programming, but it's the same copy of PD and the same patch that they're all editing at the same time. That was very surprising and interesting and fun to watch.
I definitely recommend work of Johannes Smolnik for people who do not know. I think he is a developer of GEM, the graphical.
He is, yes.
Library for pure data.
Mm-hmm. Although that was originated by Mark Danks many years ago. Mm-hmm. Are there plans for M1? I think the current version of PD is compiled for M1, but I'm not sure. One thing that confuses people is that when you start PD, you see the user interface, which is a different program. And I think the user interface is an Intel program, but I think if you start PD, the current version 52 on an M1 processor, the actual core of PD is running as an M1 program. But I'm not sure because the whole release process was very confusing this time around. And I'm actually relying on a compiled farm in Austria to generate the Macintosh version because I don't have the Macintosh credentials to sign and notarize code myself. So they have taken that on, and I'm not dead sure what's going on with PD and M1s, but I know that PD works on M1s. I'm just not sure if the distributed binary has an M1 version or not.
So actually, talking about the constant renovation of vanilla, the core project of PD, is it you and only you involved in this core project, or you actually work almost on everyday manner with some international people for the core PD as well right now?
Yeah, right now I think I'm maybe only doing about 10% of the work because most of it is being done by the Graz group, which is Christoph Ressi, Johannes Smolnik, and someone else I'm forgetting.
Thomas Grill, maybe, no?
No, he's not very active right now. I mean, not in the PD development itself. Also in Karlsruhe, there's a Dan Wilcox, who's an American but is now working in Germany. Is also a very strong and very fruitful contributor to PD. So those 2 people those 3 people, Christoph, Johannes, and Dan, between them do about maybe 3 or 4 times as much PD development as I do.
So it's besides the Wilcox version, which is called Pure Data. Yeah,
that's a different person. That's Wilk. That's Wilkes, Wilkes, and Dan Wilcox is he's different. Yeah.
Yeah. So there is actually a PD vanilla team, who contributes.
That's a fair statement. Yeah. So there's a GitHub project just called Pure Data.
So they do it on a voluntary manner, or they all researchers and they somehow. I mean, I guess the question is, how is their time compensated? So,
I'm not sure of the details. I believe that. So Dan and Johannes both have full-time jobs in art institutions. Johannes's job actually includes PD maintenance, so he is actually paid directly for that. Dan Wilcox is working in. He's hired as to support art projects, and so when art project support intersects with PD development, then he's being paid to develop PD. So, for instance, he made it possible to use this new sound file format, CAVS, and to do that, he rewrote the sound SF read, SF write, and the sound filer object. and reorganize the code for that. And he did all that. Yeah, I think that was he was paid out of Karlsruhe to do that. But other things that he does really on his own time.
Guys, we really have, I think, 5 minutes left, because it was a long talk. Anyone wants to say something? Because I probably have a couple questions which I can ask if nobody wants. Okay. What's about YouTube chat?
Ooh, that is a hard thing to do and is not very much fun. There is a program, I can't remember the name, but there is a program somewhere that that will translate a max patch into a PD patch, but it only translates the file formats, at which point you get a PD patch, but most of the objects will not have been created because they won't exist. And then you have to make a library or find equivalent objects and maybe make your own translation library, or some of the objects you can actually find in, there's a project called Cyclone, which has, I don't know, 50 or 100 max objects that are commonly used, translated into PD, or whatever you say, re-implemented in PD. So it's a hard process. It takes work. And the more stuff you've used in Max, the more complicated you made your patch and the more feature you used, the harder it's going to be to get it to work in pure data. Yeah, but it's possible. And in fact, all the IRCOM repertory that I worked on was in an early version of Max, and I have ported all that over to pure data.
How do you feel, Miller? Are you already want to escape? Or maybe you can give us a little bit more time, maybe another 10 minutes.
Oh yeah, I'm in no hurry. Yeah. Oh boy. Well, you know, the people I admire mostly are mostly dead, right? Because they're the ones who've had time to do a whole lifetime's worth of work. So I would start with Terming, I think his first name is Leonid Terming. Leon Terming, yes. And then Robert Moog, Don Buchla, synthesizer designers, Dave Smith, another synthesizer designer. And then in the software world, of course, Max Matthews and Barry Vercoe. I would hold those two up. Oh, back in hardware land, of course, Les Paul, who was a jazz guitarist, but who was also an innovator in a lot of ways. So yeah, that would be a half dozen people whose work, you know, those are people I look up to that I would hope to count myself among someday. Yeah.
Well, I actually have a related question. There is definitely a tradition in music software, yeah. And do you consider yourself a part of this, I would say, a chain, which is, for me at least, it's obvious, yeah? For example, not for example, yeah, it's Max Matthews, Barry Vercoe, and then Miller Pakett, because I think Max Matthews was a teacher for Barry Vercoe, right?
Right. Yeah,
and Barry Vercoe was teacher for you, and Max Matthews developed Music 4, which is considered the first music software. And Barry Vercoe used it to create C-Sound. And then under his supervision, you kind of were introduced into the field and you created Max. So I think there is a tradition, but do you consider yourself part of this?
Oh yeah. Yeah, absolutely. That's my direct lineage as a researcher is Max and Barry. Yeah.
what do you think in general about the music software industry? I mean, there are major companies, yeah, like Native Instruments, like Waves, like Steinberg, and they also produce innovations. For example, VST is developed by Steinberg. But have you ever been involved with any of them, or are you aware of each other? Let's say, of course you are, but was there any interconnection?
Not much. I've met the people who run Ableton and visited the Ableton whatever you call it, corporate headquarters in Berlin once when I was in Berlin. So we're friends, you know, but we haven't actually worked on any projects together. Yeah. So yeah, the thing that happens to me is all the time that I really have for working on software, I'm pouring into PD. And if people want to use PD, then they can have it. So it doesn't make sense for me to get involved in commercial projects because that would just take time away from PD for me.
There is a legend actually that Ableton was first prototyped as a Max patch. Is that true?
The people at Ableton don't say that that's not true. there's an interview with I've forgotten
Robert Henke. No?
Henke, yeah. There's an interview I think with Henke where he says, yeah, no, actually, Ableton was a C program from the start, but he had been working on making loopers in Max, and then wrote his own program when he wanted to do things that were more focused on looping than Max was. And not specifically looping, I think, but that sort of Ableton, you know, live DJing thing, right? He was making Max patches to do that, and then finally, in frustration because he had sort of reached the end of what Max was able to do, he then turned to C coding and then made Ableton. Yeah.
Oh, I have a question. Can I?
Yeah, please.
So, what you would recommend to learn, like maybe book or source, to learn the development of sound software?
Oh boy, there are not very good sources for that. In fact, Sergey is now taking a course in software in digital signal processing development at UCSD, being taught by Tom Erb. And there are various kinds of resources on the web that you can look at, but I don't know of any good introduction to digital signal processing coding or interactive electronic music coding in general.
Okay, thank you. Maybe books or something.
Yeah, well, I think, you know, maybe just look at the Max mailing, the PD mailing list for a while and look at what people are talking about.
Yeah,
that might be the best way to find out what's going on and what things people try to do.
Okay, thank you very much.
Well, maybe to kind of start to resuming things, yeah, and maybe a couple of general questions, if you don't mind. For example, if not an academic career, and if not the career of the developer which you have, what would you imagine yourself to be?
If not academic and not a developer, what would I do? I would.
I know that you play banjo, I think, right?
No, I play guitar and a tiny bit of violin, but not very well at all. I would never actually survive as a musician, right? As a career, I think I would just I would work in a research laboratory somewhere. I did a little bit of satellite tracking when I was a kid. You know, at MIT Lincoln Laboratories, so I was computing orbitals for Earth satellites, and that's a lot of fun. I could go back to doing that.
And do you have any favorite music genre?
No, I just you know, I tend to like experimental music more than whatever you say, popular or classical music. But as long as it's new and interesting, then I'm interested in it. Yeah.
But I think you quoted Pink Floyd in some of your assignments.
Oh yeah. So I do listen to popular music, and but then if you're asking me, yeah, what's your favorite music? Well, Pink Floyd is a good touchstone. You can use that as a teaching tool because people know it. But I wouldn't consider that something that I would actually go out of my way to listen to, right?
And can you say that something? What actually inspires you to go on and to do stuff that you are doing? And do you plan to continue actually once you retire this year? Yeah.
Yeah. Well,
are you still gonna be doing something?
Oh yeah, I have ongoing collaborations with several different people, and so I probably will devote more time to these artistic collaborations than I've been able to as a faculty member.
But was teaching inspiring at some point? I mean, all this communication with the younger generation, or you got tired of it?
Well, both. I enjoy it, and I'm getting a little tired of it. Or more to the point, I think I would be pretty happy just continuing to teach for another couple of decades. But there are many young people who probably are better teachers than I am, and I don't want to displace someone else's career, you know. And the truth is, I don't need the money anymore because I can retire at this point. So it seems like a better thing for me to do for the world to simply retire and focus on what I do best, which is probably the artistic work and the research. I think I'm an okay teacher, but I think there are better teachers out there.
So it's in a way was the question about your personal future, how you see it, but maybe we can finish with a question about the future of music, which is related to everything I think the software developers do and electronic musicians. There is this constant notion of future of music, which is probably technologically defined. What are your thoughts about the future of music?
It's a huge mystery to me. I don't know what's going to happen now. I feel like music itself is not changing very much right now, and what I suspect what usually happens after periods of stasis in a particular art form is that people break out of whatever the habits are and do something radically new. And so I'm hoping, for instance, in the early 1900s, the exploration of atonal music was an example of that. There was a feeling that tonal music, the romantic music, had gone as far as it really could go, and then it was time to stop that and try something radically new. And I feel like we're at a stage right now in musical development where that might be true again. But the other thing that's going on is that music and the other electronic arts are getting more and more tightly fused together. And so I see a lot of interesting development going on now in the sort of interfaces between art and visual arts and installation art and video and music and computer algorithms in general. So there at the interfaces between those disciplines, there's a lot happening.
In particular, I know you talked about this a little bit, but do you think that neural networks is the hottest topic right now?
No. I don't know what the hottest topic is. The topic that interests me the most is portable computing. Trying to get small processors to do things that can be built into works of art. That seems to be very interesting to me right now.
is a mobile device and mobile app development related to this topic? Like in particular, I'm talking, of course, Android and everything.
Oh, yeah. I'm not terribly excited by Android devices. So in general, things that run on cell phones or run on tablets aren't as interesting to me as things where you can actually build a computer directly into a device that does something different from what a cell phone does, right?
So the physical computing, Arduino, Raspberry Pi, these things.
That stuff, yeah, right. That's I find that much more interesting than cell phones, yeah, or Android in general. Android is big and kind of ugly, and the programs that you run on these very portable machines, you can run very small, simple, direct programs that really do what you want to have happen.
Yeah, I think the biggest problem they have right now is actually the DSP and availability of actually signal processing.
Yeah, I think so too.
Because if it exists, it's either too complicated and low quality or very expensive in comparison to the cost of the device.
I think that's true, and that's changing gradually. But but we're just now sort of at the point where it's becoming possible to get high quality DSP on a portable device.
I think it will be in the next 5 years. This will be solved.
Right. Yeah. It's miserably hard right now, as I can attest. But I think in a few years it'll be pretty easy. Yeah.
Well, my personal thought is that things you did, they really influence the music and the arts in general, and that these instruments which you developed and the paradigm you established, they actually the seed of that future of music. And we can see it nowadays, because if we look into the intersections of music and arts, into the sound arts, so-called, the dominating instrument there is a Maximus pure data. And I think that it's in a large amount is thanks to you that something new probably will appear and music will gradually change and evolution will continue to happen.
Well, I hope people will keep using my work. So yeah, I'm in favor of that.
Well, thank you so much, and it was a great honor for us. And I think it's first time you were talking or sort of talking to Russian audience.
Yeah.
We could not afford translation, unfortunately, and I want to apologize to all the people here. But yeah, you've never been to Russia, actually, or have you ever been?
No, never have. Someday I hope to come, but
well,
but not this year. Not this year.
Hopefully the pandemic will go away and we'll be able to invite you, and probably gonna have this kind of event again in person.
That would be fun.
Thank you very much, and guys, let's do a round of applause for the great Miller Pakett.
Well, thank you all for coming.
A lot of inspiration, a lot of thoughts to think, to discuss, and thanks everyone as well. I know it's already a bit late in Moscow. For everyone who joined us, and special thanks to Vitalina for managing everything from Moscow.
Yep, indeed.
We did a recording, I think, if you don't mind, and we had a stream which will be on YouTube, I think, automatically. So
okay,
if you don't mind, it will be available online.
Okay, and perhaps there's a transcription. Perhaps it'll get transcribed and there'll be some way to automatically translate it, but it probably won't translate well.
Yeah, with the use of neural networks. And,
yeah, right. Yeah.
Thank you very much, and have a great weekend, because it only starts in California, and everyone else in Moscow and in Russia, wherever you are, just stay safe, have a nice time, and see you soon.
Right. Okay, excellent. Thank you. Bye.
Thanks.
Спасибо.
Thank you.
Record.